try and do. So we're going to try and do all of them. Okay. So there's this question. Frequently, it's a very common question, which is the oxidation of FeSO4 with KMnO4. And the KMnO4 is acidified. So we're going to try and figure out. So we're going to try and figure out what will happen in this particular reaction. So, सबसे पहले तो what substances do you have? You've got Fe2 plus. I've got SO4 minus 2. And I've got K plus 1. I've got MnO4, which is minus 1. And I've got H plus 1. Okay, so I've got all this stuff. So इनके बीच में ना reaction देखना है. So I just want to figure out the reaction. So I'll open the data booklet. नहीं है मेरे पास, एक second. Let me open the data booklet. As I remember, Fe2 plus SO4 minus 2. ये सारे लिखे हुए. ठीक है, Fe2 plus SO4 minus 2, K plus 1, MnO4 minus 1, and H plus 1. These are my reactants. The higher one is going to gain electrons. The lower one is going to lose electrons. Okay, so I'm just going to rub this off. Okay, let's try and solve this. सबसे पहले, I've got as the first one. अच्छा ये सारा मैं पहले एक सेकंड रब कर लूं जल्दी से. अच्छा, so I've got one second. As the first one, Fe plus 2. So Fe plus 2 सामने, ठीक है. Fe plus 2 is where's Fe plus 2? I've got Fe plus 2 over here. This Fe plus 2 can gain 2 electrons. That's one equation. Then I've got another equation for Fe plus 2. Okay, that's another possibility that can happen. Similarly, I've got the K plus 1 equation. Let me just rub this off. So now I've got the K plus 1 equation as well. और क्या था? SO4 minus 2, MnO4 minus 1. MnO4 minus 1. I've got MnO4 minus 1. I've got 2 equations. So there's MnO4 minus 1. There's another MnO4 minus 1, and it's with acidified. So it's H plus 1 as well. And I had one with SO4 minus 2. So I think there are 2 places where you can find SO4 minus 2. There's one of this, and there's one of this. So I've marked all my reactants, right? Remember, it's supposed to be a reactant that loses or gains electrons. So who gains electrons? The one that has the highest potential. Right now, the highest one is with 2.01. 2.01 मतलब लगा लो हिसाब, ठीक है. Compare it with everyone else, 0.17. ठीक है. Even if you compare it with the previous ones, it's more 1.67. You got 1.52, so it's more positive than all of the rest. So SO4 minus 2 is the highest potential, right? So it is the one that's going to gain electrons, but you can't use that equation because in this equation it's S2O8 that's gaining electrons, not SO4 minus 2. So I'm going to cut that out. Okay, because it's not my reactant that's gaining electrons. You clear, Umar, Shia, Naseeb, Alicia, Anna, is this clear? अच्छा, फिर अगले पे चले जाओ. Okay, what's the other one then? Who gains electrons? The highest potential, right? So out of all of them, and make sure you should have a data booklet yourself as well. अच्छा, so who's the highest potential now? It's 1.67. Okay, that's the highest. So the highest is going to gain electrons, and here it is gaining electrons, and that's fine. There's nothing wrong with that. Okay, it's one of your reactants that is gaining electrons to form all of this, right? So this equation is fine. तो हमारा काम हो गया, ठीक है, आधा काम हो गया. We figured out the highest potential, right? Now we're going to figure out the lowest potential, the one that loses electrons. The lowest at the moment is minus 2.92. But I can't use that because if I choose that as the lowest, then it's potassium that's losing electrons. I don't have potassium, so I can't use this equation. Acha, who's the lowest now after that? I guess it's minus 0.44. If I choose that, acha, it's minus 0.44. If I choose that, then it's going to be Fe that's losing electrons, which again is we don't have Fe, okay? So that's not going to be the one. Acha, or कौन है lowest? Potassium. What about the other ones on the other page? Anyone having a low potential over there? Acha, we have 0.17. Okay, but again, that can't be used. This 0.171. Okay, we can't use that because it's SO2 that's losing electrons. We don't have SO2. So piche end mein reh gaya, you've got 0.77, which is this one. Because all the others got rejected. So this is the only one that's the lowest. So that's going to be the one that loses electrons. So I figured out the highest, I figured out the lowest. Okay? You clear? And let me copy this as well. It's is that clear? Yes or no? So I'm going to copy the two equations. I'm going to 4 minus 1 plus 4h plus 1 plus 3 electrons. And 1 second. That's a F plus 3 electrons, MnO2 plus. So it's in equilibrium with MnO2 plus 2H2O. And it's 1.67 volts. So दूसरी side पे you got Fe3 plus 1 electron. And this is 0.77 volts, the lowest potential. Okay, so I'm going to copy these two equations. I say ये अब थोड़ा time consuming होगा, ठीक है? I mean this whole thing, because we have to remember we have to do a second reaction as well after the first reaction. I said now I've written down the two equations. I'm going to write down the whole reaction. The higher gains and the lower one loses. Multiply this by 3 so that the electrons gain and loss are equal. Okay, you have to make them equal. And add up the reactants. What are the reactants in the first equation? The reactants are these. And what are the reactants in the second one? It's these. So add them up. It's going to be MnO4 minus 1. It's going to be MnO4 minus 1 plus 4H plus 1 plus 3 Fe2 plus. And you've got your products, which is what are your products? In the first one, it's MnO2 and 2H2O. Of a second में किया, it's 3Fe3 plus. And I've figured out my reaction. Okay, that's my reaction. So after this first reaction, okay, you can measure the E0 cell. It looks perfectly fine. 1.67 minus 0.77. I said now after the first reaction, I've got all these products. What are my products? It's MnO2. I've got 2H2O. And I've got 3 Fe, 3 plus as well. These are my products. Now, let's say in the question they've stated that, so let's say in the question the FeSO4 is in excess. Okay, so that means there's still some FeSO4 that's left. And You could link the thing. There's plenty of FeSO4 available. It's in excess. So there would be some leftover Fe2 plus that will still be present. And obviously there's going to be SO4 minus 2 that would also be present, and it's acidified, so there would be H plus 1 as well. So this will be so this one is still present. ये जो शुरू में reactant है, it's some of the excess FeSO4 is still present. Remember, when you do a reaction, you don't add exact amounts. ठीक है, you दोनों की quantity डालते हैं, you want the reaction to go to completion. ठीक है, so you keep adding stuff until the reaction is still happening. You stop adding stuff once the reaction is complete. So let's say there's still some unused FeSO4, right? So this is what my beaker contains. वो पहले reaction का ना product, ठीक है, it's got the product of the first reaction, which is MnO2 and all of this stuff, and it's got Fe2 plus and SO4 minus 2. Now what we're going to try and do is we're going to try and figure out whether there's going to be another reaction or not. Okay, so I'm going to open the data booklet once more, and this time I've got MnO2. Okay, and I'm trying to figure out whether there's going to be a subsequent reaction. So I'm going to do the working for that now. अब उसमें ना I'm going to, since I no longer have MnO4 minus 1, so I'm going to remove these equations for MnO4 minus 1. ठीक है, वो SO4 अभी भी है, the potassium is there, ठीक है, let's just the Fe2 plus is there, but now I've got Fe3 plus as well. So I'm going to add the equations for Fe3 plus as well. At the moment we don't know what the at the moment we don't know what the direction is going to be. So I got Fe2 plus, I got Fe3 plus. I have MnO2, which is this one. I've got MnO2 over here as well. Or I don't have MnO2 anywhere else. I've got SO4 minus 2, so those equations are already marked. So again, फिर वापस जाता हूँ, ठीक है? मैं फिर वापस जाता हूँ कि this is the situation of the container after the first reaction. ये तो clear है सारों को? Umar, is this clear? Is this clear? That after the first reaction, your container has all this stuff. So let's move on. Okay? Let's move on and try and predict the second reaction. Will there be a second reaction? So Alicia, why का क्या मतलब? It's I guess it's yes. अच्छा ठीक है. अच्छा so अब इस पे आ जाते हैं. Highest potential, right? I'm not going to use this. The highest one, 2.01. That's the highest, but can't use that because I don't have S to it. Which one is the highest after that? Okay, looking for the highest potential. It's coming out to be 1.67. That's the one that's the highest, right? But I can't use that as well. Why? Because it's MnO4 minus 1. I don't have MnO4 minus 1. So I can't use that equation. So I'm going to remove that as well. I say if I remove that, which one is the highest? I think it's 1.23. That's the highest. So that one is the highest. And that is fine. So that means MnO2 gains electrons. And I'm going to copy this equation. I figured out who gains electrons. So my beaker had my beaker had MnO2 in it. And I figured out that MnO2 is the one that has the highest potential, and it's the one that's going to gain electrons, right? यहाँ पे देख लिया, MnO2 is the one that's gaining electrons. So I'm going to write down this equation. So it's और फिर देखते हैं लूज कौन करेगा. MnO2 gains plus 4H plus 1 plus 2 electrons and it forms Mn2 plus plus 2H2O. And the value is 1.23 volts. Okay, so I've written down this equation. I'm going to try and figure out who loses electrons. So one by one, if you loses electrons, the one that has the lowest potential, minus 2.92. K is going to lose electrons. No, that's not possible. I don't have K. Who has the lowest potential? It's minus 0.44. Fe is the one that's going to lose electrons. I don't have Fe. Okay. Then you have the lowest, minus 0.04. Fe again is going to lose electrons, but don't have Fe. Who else has the lowest potential? सबको निकाल कर if you keep on, the lowest one would come out to be 0.77. That is the one that's going to lose electrons, and I do have Fe2 plus, right? So that is the one that's going to be the lowest. So वापस जाके I'm just going to select the lowest now. एक second, stuck हो गया. अच्छा तो क्या था Fe3 plus 1 electron in equilibrium with Fe2 plus, and that was the equation I selected. That was 0. As that was 0.77 volts. So higher gains and the lower one loses. इसका मतलब है, in the first reaction, the MnO2 got produced, and that MnO2 ended up doing a further reaction with Fe2 plus. Is this clear? Is सारों को clear है? So I'm going to multiply this equation by 2 so that the electrons are equal, and I'm going to add the two equations up. And if I add them up, it's going to be time consuming. It's otherwise. I say so. It's MnO2 plus 4H plus 1. That's my reactant. And then the second one, the reactant is 2Fe2 plus. And in the so I'm going to tell you how to save time as well on this. Nee, Hasib, remember, nothing will happen. Okay? You're just doing that for balancing. That's it. Okay? I mean, you're just making an equation. We're just trying to balance it. That's it. The charge or the potential, nothing will happen to it. Okay? ये बस वो this is just for the sake or purpose of making the equation. Okay? Otherwise, because the number of electrons gained and lost must be equal. So मैंने कहा था, I previously told you that nothing happens to the potential. The potential is the electrode. That is fixed. Whether you go backward, whether you go forward, that's a relative thing. It depends on the higher gains, the lower losers, right? So even if it goes backward, it's still 0.77. If it goes forward, it's still 0.77. If you multiply by 2, that's just for balancing, nothing else. Okay. So as a product make here, you got Mn2 plus. But be very careful with this. The potential does not change. आगे जाके पढ़ेंगे, you can change the potential, but the standard potential is fixed. As you got Mn2 plus 2H2, and you got product. What is your product? That's 2Fe3 plus. So बन गई equation. You found your reaction. This is the second reaction. So basically, your entire reaction. No, just 1 second. एक से मैं reload कर रहा हूँ. Just 1 second. तो बस आखिरी चीज करते हैं कि what I'm going to do is I'm going to add the two reactions up. Do you remember my overall reaction? I'm going to try and make an overall reaction. Okay. So the overall reaction, would be a sum of the two, because there are two reactions happening. So the overall reaction is start adding them up. It's going to be MnO4 minus 1 plus 8H plus 1 plus 5Fe2 plus. Okay, so it's MnO4 minus 1 plus 8H plus 1 plus 5Fe2 plus. These are my reactants in both reactions. Okay, so I'm making an overall reaction combining the two. Or the MnO2 gets cancelled out. You got an MnO2 over here, you got an MnO2 on the left side. So the MnO2 will get cancelled out. What's on the right side then? It's Mn2 plus. Okay, so you got Mn2 plus, and you've got water को add करें. 2 water here, 2 water on the other side. That's 4 water molecules. And what are the other products? That's 5Fe3 plus. Okay, so you have 2 Fe3 plus here, 3 Fe3 plus here, so that's 5 Fe3 plus. The MnO2 will get cancelled out if I add them up. Okay, you got an MnO2 on the right side, you got an MnO2 on the left side. So your overall reaction is this one. Okay, that's the overall reaction, which happened in 2 steps. So what I added was I'm adding the 2 reactions. Okay, is that clear? You clear? नहीं अभी what part? I mean, you talk about this reaction. I mean, this is a familiar reaction, right? You must have seen this equation a lot of times, right? So this is where it comes from. This is how you make it. Okay, it's actually a 2-step reaction. But the problem is now that took a very long time. I mean, doing this took a very long time. So इसका फिर आसान तरीका क्या है? Remember this for MnO4 minus 1 specifically, because this equation is asked frequently, right? It's a very frequent question, this one. So either you've got 2 options. Either memorize this equation, because imagine doing all of this in your exam. So you've got 2 options. You can either memorize this, okay? Or the second option is that when we were doing the first equation, okay, which equation did we choose? Okay, if I go back to the data booklet, when we were doing the first equation, I chose the 1.67 volt equation because that was the highest potential. जिसकी वजह से MnO2 was getting formed. What I should have done was I should not have selected if I want a shortcut, if I want to do it in one step, I should have selected the 1.52 volt. क्योंकि end में Mn2 plus ही बना ना. So what we did instead was MnO4 turning into MnO2 and then MnO2 turning into Mn2 plus. So it actually took an extra step. So the shortcut is, which you should remember, is that whenever MnO4 minus 1 is involved, just don't use the 1.67 volt voltage potential, because if you use that, then the whole reaction will basically get broken down into two steps. It will first form MnO2, and then in the next step, the MnO2 will get converted into Mn2 plus. So instead, do that in one step. Use the 1.52 volt from the beginning. The second step की ना फिर जरूरत ना होती. So that's a shortcut for this specific reaction. Okay, to avoid the two steps and to directly reach this equation, either memorize this equation or use 1.52 volt, the MnO4 minus 1 H plus 1 equation. I mean, this is just a hack that I'm trying to tell you that so that you can avoid the whole two steps. Instead of the 1.67 volt MnO4 minus 1 H plus 1 equation. Okay, so both equations over here are MnO4 minus 1 4H plus 1, MnO4 minus 1 8H plus 1. They've got different potentials. Highest one is 1.67, but instead of using that, always use 1.52. So for those steps, you can, for this specific reaction, this one is a very popular reaction that comes very often. तो क्योंकि अगर हम पूरा डिटेल में जाएंगे ना फिर तो पूरा दिन लग जाएगा इसको सॉल्व करते हुए, ठीक है? So just to be quick for this specific reaction, and this only applies to this specific reaction. It's a very popular reaction, so only this specific reaction. हाँ मतलब वैसी एंड में तो यही होगा ना. Actually, even if it's not written that it's in excess, right? Even if it's not written, even if they don't tell you that it's in excess, what happens is, think of the first molecule, like the first molecule of MnO2, right? Like you're doing titration. ऊपर से आप Fe2 plus डाल रहे हो. So the MnO2, the first molecule of MnO2 turns to Mn2 plus. And ये दो steps. Sorry. So the first molecule of MnO4 turns into MnO2. And while the reaction is happening, there would be still Fe2 plus left, right? So the MnO2 will then further react with Fe2 plus to form Mn2 plus, right? So even during a reaction, things are in excess. वो तो end में जाके चीजें खत्म हो जाती है ना, but while the reaction is happening, things are always in excess. They're always available. Alicia, do you get the point? I said now there's one more. I said there's one more reaction, and that one is even lengthier, okay? So the way you should think about it is, पहले तो ये मिटाए जरा, या आखिरी वाला कर लेते हैं. I said that question was just a 2-mark question. मसला ये कि it was just a 2-mark question, and solving that question required a lot of time. Okay, this would be the last one. Most of the questions are going to be very simple. Acha. Now I'll do it over here. The question was about vanadium reacting with Fe3 plus. So now what you can think about it is, okay, there's a reaction of vanadium with Fe3 plus. So one of them is going to get oxidized, the other one is going to get reduced, and you have to figure that out, right? So you got Fe3 plus, and you got Fe, पता नहीं Fe2 plus or 3 plus, the same as social. That's vanadium was getting oxidized, so no, Fe2 plus was getting, it must be, sorry. This one was probably Fe. I said this one over here was probably Fe2 plus. I said vanadium plus Fe2 plus. So I said let's find Fe2 plus. I've got Fe2 plus, I've got Fe2 plus here, right? दोनों के potentials देख लो, 0.77, 0.44, and vanadium, right? You got vanadium right on the other side. So I've got vanadium on the complete opposite side. And here's vanadium. Look at vanadium. That's a lower potential. What does a lower potential do? It loses electrons, right? And look at Fe2 plus, the higher potential, 0.77. That gains electrons. Is even lower, है ना? Anyway, Fe3 plus के साथ था. The reaction was with Fe3 plus. Let me correct that. The reaction was with Fe3 plus. Okay, so the higher potential gains electrons. So this is the higher that gains electrons. So vanadium and Fe3 plus. Fe3 plus gains electrons, higher potential, and vanadium over here, lower potential, it loses electrons, right? Now, so this is the lower potential. It was minus 1.2, right? So it loses electrons, and Fe3 plus, T3 plus, that was 0.77 that gains electrons. Okay, is this clear up to this point? ये clear है यहाँ तक? But I'm not going to write the equation right now. Fe3 plus gains electrons, 0.77. And vanadium, on the other hand, loses electrons. That's minus 1.2. Is that clear? Because this reaction is so lengthy, I don't actually want to write all the equations, right? It's a very lengthy reaction. Now, one way to think about this is, if this remains the higher potential, it will continue to gain electrons. If this is the lower potential, it will continue to lose electrons. So keep this in mind, 0.77. Higher would always gain electrons. The lower would always lose electrons. So let's look at vanadium. Keep the iron equation in your mind. It's 0.77 volts. Okay, up steps. I don't want to break it up. It's going to become a very lengthy question. So what I'm going to do is, नहीं वो तो option, लेकिन it is the higher potential, right? If it had not been the higher potential, then it would not have gained electrons. Abhi, is that clear? Although उसके पास वही option, it has two options. I mean, it had actually two options. Fe3 plus could have gained 3 electrons. Fe3 plus could have gained 1 electron, because 0.77 was the higher potential, which is why I chose that. ठीक है. लेकिन अगर वो higher होता ही ना, तो then it would not have gained electrons. Nothing would happen to it. But it's the higher potential, so it gains electrons. Now I'm going to skip all the steps. It's going to be very lengthy that way. Fe का ना इधर side पे लिख देते हैं. I'm just going to write it over here. So it was the higher it gained electrons. Yeah, it's 0.77 volts, right? So vanadium turns into what? Vanadium 2 plus. So after the first step, what is formed? Vanadium 2 plus. Now I've got vanadium 2 plus. Why did it lose electrons? Because it was the lower potential, right? Now I've got vanadium 2 plus. And look at vanadium 2 plus. It is still the lower potential compared to Fe. So Fe is going to gain electrons, and vanadium 2 plus is going to lose electrons again. And it will become what? Vanadium 3 plus. Now, what will happen to vanadium 3 plus? It's vanadium 3 plus is 0.34. It is still the lower potential compared to Fe. So Fe3 plus will continue to gain electrons, and vanadium 3 plus will get oxidized further to form VO2 plus. Or VO2 plus pe jaake reaction will stop, because VO2 plus will not get oxidized because it no longer is the lower potential. It's 1 volt, right? So now VO2 plus will not lose electrons. So the reaction will stop at this point. So you can continue making this reaction. There would be 3 reactions, 3 steps. Fe being the higher potential, which we did the first step. Fe being the higher potential is 0.77. It wants to gain electrons. Vanadium being the lower potential wants to lose electrons, becomes vanadium 2 plus. फिर vanadium 2 plus को देखो, it's still the lower potential, so it would lose electrons again, become vanadium 3 plus. But look at vanadium 3 plus, it's still the lower potential, so that would lose electrons again and it will become VO2 plus. If you look at VO2 plus, then VO2 plus is no longer the lower potential, so it will compare to Fe. So now it will not lose electrons. तो यहाँ पे जाके ना, this point, it's this point. You start at this point and you end at this point. तो ये समझ आया कि इसको, instead of doing all the steps, I just did it in one go. That vanadium will get oxidized and it will continue to get oxidized until it forms VO2 plus. Is that clear? तो वो बारी बारी reaction बनाना पड़ेगा. You have to make 3 reactions now. ठीक है, you have to make 3 reactions. The first one, Fe3 plus with this one. अब वो पूरा टाइम लग जाना उसी के अंदर ना. This was an actual question and it was just a 2-mark question. So first reaction, Fe3 plus gains electrons. Vanadium loses electrons. I would have to multiply the Fe equation by 2. So I'm going to make it over here. It's going to be 2Fe. So I'm making it with the first one, right? So it's going to be 2Fe3 plus vanadium. And it's going to form what? The product is going to be 2Fe. Just bear with me. 2Fe2 plus, and the other product is going to be vanadium 2 plus, right? So then what happens after that? Fe3 plus gains electrons again. Vanadium 2 plus loses. Now you have vanadium 2 plus. It's a lower potential, so it loses electrons. So again, as electrons barabar hai, so I don't have to multiply Fe with anything. So it's going to be Fe3 plus. And vanadium 2 plus loses electrons. So vanadium 2 plus. The Fe3 plus gains electrons again to form Fe2 plus. And vanadium loses electrons to form vanadium 3 plus. अच्छा, फिर क्या होता है? फिर Fe3 plus is still the higher potential, it gains electrons. Vanadium 3 plus then loses again electrons. The electrons are already balanced, so it's going to be Fe3 plus and vanadium 3 plus plus H2O, and product make I got VO2 with a charge of 2 plus and plus 2H plus 1 plus 2 electrons. Sorry, plus 1 electron. And once it forms VO2 plus, then after that, there would be no reaction, because then the Fe will not be the lower, Fe3 plus will not be the higher potential. Or actually higher potential hoga, so it's not going to lose electrons. So I'm going to get 3 steps. And I have to, at the end of the day, I have to add them up. Dono sides mein jo cheezein, I'm going to cancel those. What else gets cancelled out? Water, vanadium, I guess everything is fine. So it's going to be 4 Fe3 plus just 1 vanadium, and on the other side it's going to be, I just saw यहाँ पे Fe2 plus था. So it's going to be 4 Fe2 plus, and there's water as well on the left side, and over here I've got VO2 plus 2H plus 1. तो ये पूरा एंड में रिएक्शन बना है. ठीक है, इज दिस क्लियर? इसका मैं ना एक डिटेल्ड वो भेजूंगा वीडियो लेक्चर, ठीक है, on the last one as well. The detailed one is where I do everything stepwise, and that's going to take it's going to be a 30-minute video just explaining this. ठीक है, लेकिन overview clear है, and this was actually a past paper question and it was just worth 2 marks. तो 2 marks का तो खुद ही सोचो कितनी एफर्ट लगानी है. ठीक है, most of the questions are going to be very straightforward, most of them. For the MnO4, these chain reactions are problematic because they just waste a lot of time. For MnO4, just remember कि MnO4 के केस में ना, ये जो acidified MnO4 है, don't use the 1.67 volt equation. Instead, use the just इसको ignore ही करो 1.67. If you use the 1.52 volt equation, then you would not have to do all the steps. वो आप direct Mn2 plus पे पहुंच जाओगे, and that will skip the steps. So that's a hack for that equation specifically. बाकी ज़्यादातर questions के अंदर you don't have chain reactions. chain reactions are only a problem when a certain element has many oxidation states. ठीक है, यहाँ पे vanadium के केस में you have an issue because it can get oxidized in many steps. तो यहाँ पे chain reaction would be an issue. ठीक है, तो ठीक है, इसका मैं भेजूंगा ये chain reactions का. I'll send you a more detailed version of this one. ठीक है, a video lecture on this. ठीक है, और make sure इसको थोड़ा सा practice करो. ठीक है, you can think of anything. I'll obviously I'll try and send questions today. ठीक है, for practice. ये वाला chapter, this is slightly difficult. ठीक है, just remember that. Difficulty is just you have to be just a little bit diligent or careful about things. ठीक है, चलिए कल फिर करते हैं discuss. Okay everyone.